In today's lesson, we are going to be looking at area problems of composite shapes. Now, we've already kind of done this in a previous lesson. However, we're going to be adding in unit conversions, which we've also looked at a previous lesson. So we're basically going to be combining a couple concepts that you might find in the real world, right? Because not everything you deal with in the real world is going to have the same units of measurement. So you might have to make some conversions. So question 1, you are purchasing blinds for your window that you measured as 180 centimeters wide and 150 centimeters high. That store sells blinds in inches. So what width and height would you or should you ask for? So we have our window here, you could say, is 180 centimeters wide and 150 centimeters tall. I need to be able to convert this to inches, so I need a unit rate. I need to know how many inches are there in 1 centimeter. So this is an easy thing to do. You can easily calculate or easily find this on the internet if you Google it, ask Siri, whatever the case may be, or you just might know just from common knowledge. But it's 2.54 centimeters in 1 inch. So we're going to use that unit analysis and this unit rate that we've talked about in previous lessons to make this conversion. So we're going to start off with our width. And in this case, we have 180 centimeters. Those are the units we have. We're going to multiply it by our unit rate, and we're going to multiply it by the units we want, which is 1 inch. Divide it by the ones we have, centimeters, which essentially works out to 180 divided by 2.54. And if we round, we get 71 inches, roughly. So our width is going to be 71 inches. Our height, we'll look at next, and it's going to be exactly the same calculation, except instead of 180, I'm using 150 centimeters. Multiplying it by our unit rate, 1 inch divided by 2.54 centimeters. Basically 150 divided by 2.54, and we get 59 inches roughly. So the height and width that we should ask for would be 71 by 59, and that would be the appropriate units in inches. If we look at another question, so a room in our house requires new carpet. The room measures 10.5 feet by 11 feet 9 inches and has an additional 2 foot by 4 foot closet. Both the room and the closet need to be carpeted. So what is the total area to be carpeted? So I have 2 different areas that I need to add together. Because we're dealing with rectangles in this case, we know the area formula, or we should know that the area formula will equal length times width, or just LW. So that is going to be our formula that we're going to be using in calculating area. If we look at our objects here, we have 10.5, actually 10.5 is probably on the other one, 10.5 feet, and then we have 11 feet 9 inches, then we have 2 feet by 4 feet. For our closet. So I don't need to worry about breaking this up. It does look like a composite shape, but I already have enough measurements to calculate each shape individually. The only issue here is I need to get all of these units to the same unit, right? Because I have feet, feet in inches, and then just feet. So I'm going to convert everything to inches, because if I look at question B, I want to know how many square yards I'm going to have, and I already have the conversion for inches or square inches to square yards. So I'm going to convert everything to inches, and we talked about that in the previous lesson. We want to try to keep everything in the smallest units, especially when dealing with the imperial system. So that would be inches in this case. So I have 10.5 feet, so 10.5 feet multiplied by 12 inches. In this case, I don't have to worry about adding anything because they're using this as a decimal. So 12.5 feet times 12, or sorry, 10.5 times 12 gives me 126 inches. So 126 inches. The next one, 11 feet 9 inches. So here I'm going to do the 11 feet multiplied by 12, which is 132 inches. Oops, sorry, 11 feet times 12 inches. And then I'm going to add in the 9 inches on top of that, and I get 141 inches. 2 feet and 4 feet. This one is straightforward. We could go back to the table that we had in our previous lesson. Again, you could just say 12 feet multiplied by 12 inches, because there's 12 inches in a foot. Which gives me 24. So 24 inches. And then 4 feet times 12 inches is 48 inches. So now I can do my calculations. I have everything in the same units, so I can make those calculations. I have two different objects, so let's use some colors to signify it. So I'm going to say object 1 and object 2. Still going to be using the same formula, but just so I know what I'm dealing with, so I can keep track of my work. So the area, length times width, I have 126 inches multiplied by 141 inches gives me 17,766 inches squared. Again, remember we're dealing with area. Area, the units are always squared. For the second one, again, area equals length times width. In this case, 24 times 48. And I get 1,152 inches squared. In the end, I need to add up all of my areas together. So my total area is 17,766 plus 1,152. And I get 18,918 inches squared is my total area of both the room and the closet. So I have my total area squared. I know how much total area needs to be carpeted. However, when you take that measurement, or you take that information, if you go to the store, you might find that the store doesn't sell carpet by the square inch. Right? The square inch a square inch would be relatively small, and in terms of carpet, it wouldn't make sense to smell it in small increments. So you're going to sell it. They would sell it in things like square yards. So we need to know how many square yards do I actually have. So this is a different unit conversion, but again, as long as we can figure out or have a unit rate, we should be able to use that unit analysis that we've done in previous lessons to figure out how many units or how many square yards I have. So again, by having that unit analysis formula, that was the units I have multiplied by the units I want and so on. By having that formula or having that idea, we can basically convert anything as long as we have a unit rate like this, and these are generally easily defined just by asking Siri or just doing a quick Google search. So I want to figure out how many square yards I have, so I'm going to start with the units I have. So in this case, 18,918 inches squared. I'm going to multiply that by my unit rate with the units I want on top, which is 1 yard squared, divided by the units I have, so 1,296 inches squared. This essentially becomes 18,918 divided by 1,296. And I end up with 14.9 6 yards squared. So I need 14.6 square yards of carpet. You could also argue, well, in a store you're not going to get a decimal version of a yard or of carpet, so you might round that up to 15. But again, this would be rounded to 1 decimal place. The next question, the parking lot at a local shopping mall needs to be coated with sealant. So we have our parking lot here. What is the area of the parking lot? So looking at this, we see that this is a composite shape. And we need to figure out, okay, based off this composite shape, let's convert it into simple shapes where I can determine what the, where I know, or I should readily know what the formulas are for area. So I could draw a line straight down to turn that into a large triangle. And I could draw another line here to turn this into another triangle and our large rectangle. Sorry about that, blanked for a little bit. I am missing some measurements. I am missing this part here for my rectangle, right? So I am missing that width or height, you could say, and I'm also missing for the triangle. And if I wanted my triangle, I'm missing this little portion down here. The main thing I'm missing is this height, that distance, because that prevents me from calculating the area of 2 triangles. I can easily figure out this measurement down here because this entire distance is 230 meters. This portion up here is 180. So that means that that difference over there has to be 230 minus 180. So this measurement here will be 230 minus 180, which equals 50 meters. So now I know that measurement. It still leaves me with this height of my rectangle as the unknown part. What I can do, though, is I can calculate or figure out what that height is, because we should recognize that we get a right angle triangle and we have the 2 measurements. So if I isolate that right angle triangle, just for the purposes of calculation right now, I know that this base is 50, this diagonal is 80 because of the lines. These lines again tell us that these are the same measurement, and I'm missing now this height. Being a right triangle, I can use Pythagorean Theorem. Because I'm looking for a side or a leg that is not the largest side, I should be using c squared minus a squared equals b squared. Again, c is the hypotenuse, which is across from the 90-degree angle. A and b represent the 2 legs, and it doesn't really matter which one's which. They're interchangeable. So let's plug our numbers in. 80 squared minus 50 squared equals b squared. Again, you could probably enter 80 squared minus 50 squared into your calculator and get an answer. I'm going to break it down just so that we are, depending on the calculator that you have, you might have to break it down. And so if you do, just want to make sure we're all on the same page. So 6,400 minus 2,500, we get 3,900 equals b squared. Again, the last thing we have to do in Pythagorean Theorem is square root. So when we square root that answer, we get roughly 62.45 meters. And now we have this unknown height. And now we should have all of the measurements that we need to calculate the area of our three shapes. So again, shape 1, shape 2, shape 3, and then to find the total area, we would add them all up. So, shape 1, we have a triangle. The area of a triangle is base times height divided by 2. In this case, my base is 80. I'm going to multiply it by my height. In this case, the height is, we have to do a slight calculation. So the height is going to equal 30 plus 62.45. So 92.45 is my height. And divide that by 2. And we should get 3,698 meters squared. For the second object, here we have our rectangle. So the area is going to equal length times width. Our length we could say is 180 multiplied by our width, which we have calculated to be 62.45. So 62.45 times 180 equals 11,241 meters squared. And then finally, our last shape, again another triangle, so base times height divided by 2. The base is 50, multiplied by the height, which we've calculated to be 62.45. Divide all that by 2. And we get an area of 1,561.25 meters squared. So, sorry. So those are the unit or the areas for all three shapes. And again, because I want the total area, I need to add them all up. So 3,698 plus 11,241 plus 1,561.25. Add all this up. And we should get 16,500.25 meters squared. So that is the total area of this parking lot in meters squared. For B, B is asking, what is the total area in square feet? So I need to convert this to square feet. And again, that might be something that you have to do, and we'll see in a later question that maybe the sealant that we're dealing with only tells us how much it covers in terms of square feet. So here, we need to convert our meters squared to square feet. We do have our unit rate, so I can use that unit analysis formula that we had in our previous lesson. We start off with the units we have, so 16,500.25 meters squared. I'm going to multiply that by the units I want, so 10.76 feet squared, divided by the units I have, 1 meter squared. And this will work out to, or give me how many feet squared I need, or have. 16,500.25 multiplied by 10.76 gives me, 17,750, or no, 177,542.69 feet squared. So quite a large number of feet squared, which does make sense because a meter is larger than a foot. So using that, now we can go into the next question, which is asking or telling us that one 19-liter pail of sealant covers an approximate area of 2,100 square feet. How many pails of sealant are needed to apply 2 coats of sealant to the parking lot? So, what we're going to need to do is figure out how many cans of paint do I need to do 2 coats. Right? The key thing here is 2 coats. So there's different ways you could do it. You could double your area in square feet from the last question. You could double that because you have to apply 2 coats. Or you can figure out, well, how many pails do I need for 1 coat, and then just multiply that by 2. Either way, you should work out to the same answer. So the easiest thing we want to do, we do have kind of a unit rate here. Right? We have our unit rate of 1 pail is equal to 2,100 square feet. So we do have our unit rate here. So we could do a unit analysis, even though it's not a conventional one. We can still do it. So 177,542.69 feet squared. I'm going to multiply that by the units I want, which is in pails. So 1 pail, which equals, or divided by the units I have, so 21,000 feet squared. Basically, I'm dividing my area by 2,100. Divided by, and we should get 84.5 pails. So this would be how many pails it takes to seal the parking lot once. But because we're doing 2 coats, we can say multiplied by 2 for the number of coats, which gives us 169 pails, roughly. There is a slight decimal after, so 0.088. So you could argue, well, you need 106 or 170 pails. Right? So if we did round this up, you would say there's 170 pails. Again, because it's such a small decimal place, this would be fine. If it was slightly larger, I would say round up. But when you see that the decimal place is 0.088, we're using like basically 1% of a pail. So I would argue that 169 is okay. So we need 169 pails to apply 2 coats of sealant to our parking lot. The final question, how much will it cost in total, including 13% tax, to reseal the parking lot if each 19-liter pail of sealant costs $19.28? So again, I have another unit conversion or a unit rate here. I have 1 pail is equal to $19.28. So I can use this again in my unit conversion or unit analysis. I have 169 pails. I'm going to multiply that by my unit rate. I want to find the dollars, so those are the units I want. They'll be on top. Divided by the units I have, which is 1 pail. It's basically 169 times 19.28. This gives me $3,258.32. Now this doesn't include tax. I do need to figure out the tax on top of that. So to do that, what we can do, I need to figure out 13%. So 3,258.32. If I want to figure out the tax or what 13% is, I'm going to multiply that by the decimal. The decimal version of 13% is 0.13. Basically, percent means per 100. So I'm dividing it by 13 divided by 100. So multiply that, and I get the amount of tax, which is $423.58. So that's how much I'm adding on top of the cost of the pails. So $423.58 plus 3,258.32 gives me a total of $3,681.90. So that is how much it's going to cost me to seal the parking lot with 2 coats. Another quick way you could have done it, rather than multiplying it by 0.0 or by 0.13 and then adding that on top of what we've already done, the original price we've already done. Another quick way when you're dealing with percent, if you want to figure out the after-tax total, you could take the original, so $3,258.32, multiply it by 1.13, the 0.13 for the tax, the 1 for the original price, and you should find that when you do that, you do get the same answer in the end. As we did with this step-by-step calculation over here. So again, the main thing here is just being able to convert different units regardless of what we're dealing with, because again, it is very applicable when dealing with measurements, and especially looking at area of objects, and we can see how this could be applicable in real life scenarios.